Welcome to our competency-based question series, designed chapter-wise to enhance your conceptual learning and understanding. Question 13. Light falling on a glass sphere of refractive index n at an angle of incidence alpha refracts at angle of refraction beta. We need to answer the three given parts. Show that the angle of emergence is equal to the angle of incidence. So this is my angle of emergence. Let me call it as E, and I need to prove that E, it is equal to alpha. So alpha is the angle of incidence. So now applying Snell's law at first interface. So here, this is my N1 and this is my N2, that is equal to N, and N1 it is equal to 1. I have taken it as air. Now let's try to solve it out. So applying the Snell's law, sine alpha upon sine beta, because beta is my angle of refraction for this surface, that will be equal to n2 upon n1, and that is equal to n upon 1. So this is my equation number 1. Now again applying Snell's law for second interface, and in this case AB is the incident ray and the ray that is going out, let me call it as BQ, is the refracted ray. So here angle of incidence is beta, and angle of refraction is E. That is my angle of emergence also. So I can write sine beta divided by sine E. It is equal to the second medium, that is 1, divided by the first medium, that is N. That is 1 upon N. This is equation number 2. And if I multiply these two equations, multiplying equation 1 and 2. So I can write sine alpha upon sine beta multiplied by sine beta upon sine E, that is equal to N multiplied by 1 upon N. N gets cancelled out with N, sine beta gets cancelled out with sine beta, and I am left with sine alpha upon sine E is equal to 1. This implies sine alpha, it is equal to sine E, and angle alpha, that is angle of incidence, it is equal to angle of emergence. So this is the answer for part A. Now let's take part B. Complete the given diagram to represent the deviation produced in the incident ray. The deviation means that by how much angle the incident ray is bent. So I can take this incident ray forward, and I can also take this emergent ray backward. So the angle between the extended incident ray and backward extended emergent ray is the angle of deviation, and in this case this is my angle of deviation. So I can complete the diagram in this way and find the angle of deviation, that is delta. So part B is also completed. Now we need to find the angle of deviation delta in terms of alpha and beta. So let's try to do that. So for that, I have again drawn this diagram neat and clean. If this angle is alpha, that is the angle of incidence, and this angle is beta, this angle will be alpha minus beta. And also this angle is E, and we have proved this thing that angle E, it is equal to angle alpha in part A. So I can write this angle as alpha minus beta. So in triangle CAB, delta is exterior angle. And we know that the exterior angle, it is equal to sum of interior opposite angle. So interior opposite angle is alpha minus beta and alpha minus beta. So I can write delta, it is equal to alpha minus beta plus alpha minus beta. So delta can be written as 2 twice of alpha minus beta. So this is the angle of deviation in terms of alpha and beta, that is angle of incidence and angle of refraction. But for that we should be knowing that E, it is equal to alpha, and that we have proved in part 1. This is the answer for part C.
Keep learning, keep practicing, keep excelling.